Um, Good afternoon, ladies and gentlemen. Hopefully you can hear me and see the slide in front. It's a pleasure to be here today and present as part of this BESA online conference. My name is Barry Rust and I'm Energy and Sustainability Manager at Tata Steel. Today I'll present on the pathways to net zero carbon pipework for building services. If we move to the next slide. So I'll start with a short introduction to the Tata Group and Tata Steel before outlining what we at Tata Steel see as the key sustainability challenges for many of us going forward, before describing the potential pathways to carbon neutrality for steel and for building services pipework. And I'll be outlining some of the key work and technologies that Tata Steel are involved with on that journey. Finally, I'll outline some of the activities that we as an industry can undertake to drive what I call everyday sustainability. If we move to the next slide. Okay, so in terms of Tata Group, it was founded in 1868 by a gentleman called Jamshedji Tata. Today, it's a very different enterprise. It's a global enterprise headquartered in India, comprising about 30 companies in over 100 countries. The holding company, the principal investment holding company of the group is Tata Sons, and that organisation is 66% owned by philanthropic trusts, which support education, health, livelihood generation, arts and culture. So sustainable development, care for our communities is certainly at the heart of what Tata Group and Tata Steel do. And if we move to the next slide, I'll introduce you to Tata Steel in Europe. So if we click on a couple of clicks, that should take us through a little animation and hopefully not take us too far. But we're one of the most geographically diversified steel producers with operations in about 30 countries, commercial offices in about 35. Within Europe, we're one of the largest steel producers. We have two steelmaking centres shown here, and if we click again, that's in the North Netherlands and in South Wales. We have downstream manufacturing bases producing products like building services, pipework throughout Europe, as well as a number of distribution centres shown, if we click again, in green. Our R&D and environmental operations centred in the Netherlands, in South Wales, and in the centre of the UK, shown there. Perfect. Thank you for anticipating that click. So we move to the next slide. Within the UK itself, we're the largest steel company. As a steel organisation or a steel company, we act as a foundation clearly for many other industries and supply chains, employing about 9,000 people and engaged across academia, communities and many other partnerships, some of which are extremely important and we'll talk about today. But if we move on to the next slide. So in terms of this conference and the products we produce, you can see there are assets across the UK in steel making and the manufacturing of our hot formed building and industrial services pipework. All of those products are classed as responsibly sourced. You can see BES 6001 certification. We've got the widest portfolio of such certification in the world. And Tata Steel also have an environmental product declaration scheme that we're a program operator of. So that's a unique position for any manufacturer in the world. Unfortunately, we don't have time today to talk about that. So we'll talk about that another time. But in the meantime, if we move on to the next slide. So that product is backed by years of experience, many decades producing those products from those assets. Those assets continue to improve with investment programs across the steel and the pipework manufacturing facilities. That the products themselves are backed with a vast range of industry and product knowledge and expertise, which, of course, the engagement with Tata Steel is a critical part of any. I think engagement with manufacturers is a critical part of any design process, so we would certainly be pleased to further engage with the industry in this regard. So we move on to the next slide. So in terms of sustainability challenges, move on to the next slide. Thank you. These are, as we see them, climate change, circular economy and resource use, and responsible business. For this presentation, we're focusing on the pathways to carbon neutrality and carbon neutral building services pipework. And that will clearly come under the climate change aspect. There's still the circular economy piece, and the responsible business piece is a critical part of that, and they must go hand in hand. We're not really focusing on circular economy, resource use, and responsible business too heavily today, but we'd really be pleased to engage with anybody who's interested in those particular areas and want to engage with us on the work that we're undertaking. But if we move to the next slide. So a little animation here. So I think we'll just click through to that animation. I think it's important to understand on this matter that we're all aware of the narrative, but effectively sustainability megatrends are shaping our world. If we move to the first click, namely climate change, resource scarcity, and demographic shifts. The second click, this is feeding into our societal expectations in public opinion. Certainly, we're seeing that very much today, certainly regarding sustainability and climate change. That's increasing pressure on public policies and regulatory frameworks and legislation. And that's impacting on the business environment, of course, with opportunities and threats. And clearly, for the final click here, we have business stakeholders, our customers, our workforce, myself, I consider myself a stakeholder here, who all have expectations in this regard. It's really important, and it's certainly at the heart of what Tata Steel is doing, is to drive that sustainable development for our stakeholders, our customers, our workforce, and our communities. So if we move to the next slide. In partnership. The next slide. So effectively, this is, before we start, really important to understand, I think, that in this subject matter, all is sometimes not as it seems. These images here demonstrate that the subject of sustainability, and particularly environmental sustainability, which is the main focus of this presentation, is a complex matter. And whilst this image is a little bit of tongue-in-cheek, there's a serious point behind it. And it's a useful illustration that in environmental sustainability, making the optimum resource decision to limit the impact on our environment and our communities needs to consider the whole life cycle, the whole life impact, not just the immediate impact of the action. So is it better to drive a diesel car and produce emissions directly, or to invest in an electric car and make the emissions further upstream, or ideally, of course, with renewable energy? The answer is, I don't know, without understanding the whole life cycle of the car, the power plant behind it, in order to make a more informed decision. And this goes to the heart of Tata Steel's sustainable development, that life cycle approach is a critical part of any decision making relating to resources. So we move to the next slide. So our vision across our sustainable development has three dimensions. Effectively, it's about decarbonisation. And we have a target of 30% reduction in CO2 intensity by 2030, with carbon neutrality by 2050. It's about working with other industries to leverage circular economy, ensure nothing goes to waste. And it's to continue to operate as a responsible business that benefits people, partners, and society. So moving on. So back to those, one more click here, back to those three challenges. So there's some detail here, which is a nice summary about where we want to go with carbon neutral steel making, about driving life cycle assessment, about minimizing resource use, not just within Tata Steel, but across the supply chain, and about leading in transparency and reporting. Some of these areas we won't have time to talk about today, but as I said earlier, really willing to engage. And if we move on to the next slide. So now we're going to talk about the pathways to carbon neutrality for steel and piping systems. And if we look at those pathways, a good place to start is with history. And this slide here looks at the historic steel embedded performance related to energy intensity. And you can see the massive strides that the steel industry has made. It's since the 70s up to, this is quite aged data now, but up to 2000. And demonstrating that the improvements that a number of industries have made in that regard. And if we move to the next slide, this slide actually shows the carbon intensity of steelmaking from the early 90s. And since that time, there's been about 15% reduction in carbon intensity. And the variation you see around that trend relates to a number of variables: asset disposal, asset investment, But now we're getting towards physical limits of what's possible in terms of carbon reduction in steel making. And therefore, to make further reductions, we need new technologies and technological breakthroughs, and that's what we'll move on to talk to now. So if we move to the next slide. So this brings us to roadmap options and potential pathways to carbon neutral steelmaking. In the short term, this involves utilizing best available technologies and aligning our asset strategy to ensure we don't make decisions today that impact on our decarbonisation investments and our agility tomorrow. In the medium term, it's about carbon avoidance in emissions to air and water, and rapid carbon avoidance utilizing carbon capture, storage and usage. And in the longer term, it's looking at new and scaled technologies to deliver carbon or decarbonisation through carbon neutral steel making, utilizing low CO2 steel making processes like a technology I'll tell you about called Hisana, which is a Tata Steel technology, but also other technology, Hisana I mentioned. So this was initially developed by the ultra-loose low CO2 steel making consortium called ULCOS, and Tata Steel bought the rights to this technology from that organization a few years ago. And we've invested in a large-scale pilot plant, around 60,000 tons annual capacity, where we've been running trials to develop and optimize the technology. The benefits of Hisana become clear when you compare it with traditional Boss steelmaking technology, which requires coal preheating and iron ore melting prior to going into the blast furnace. With Hisana, these processes are not required prior to entering the Hisana vessel or cyclone. So we can directly put them into that cyclone without any pre-work. And the benefit of this in terms of carbon reduction were assumed to be around 20% before large-scale trials took place. But those large-scale trials now demonstrate around 50% benefit improvement. So it's not total decarbonisation, but it certainly is going a long way to decarbonising the iron-making process before making steel. And there are further benefits too in terms of reduction in particulates to air and other emissions, and also the ability to utilise higher scrap levels with this process when compared with traditional blast furnace steelmaking. Scrap steelmaking isn't the total answer to decarbonisation. There are lots of issues with using higher levels of scrap on the cleanliness of the steel and the quality of the products, but when managed properly can certainly help. And it's also well suited, the configuration of this Hisana equipment, well suited to carbon capture and storage with a potential 80% reduction in CO2 emissions. The next steps for this Hisana technology is further proving of the technology, but it's just about there today, and it's really about scaling it up. If we move to the next slide. So I already said that in kind of rapid decarbonisation or rapid carbon avoidance, it'll be about carbon capture or storage initially. And this, of course, aligns very much with that Hisana technology I've just mentioned a few moments ago. Clearly, this is an interim measure as carbon is still being produced, albeit it's being captured. And whilst an interim measure, it does offer opportunities for rapid carbon avoidance. There are challenges around carbon capture and storage, there is no doubt, but one solution and technological solution for storage is to use the depleted gas fields and oil fields in the North Sea. Tata Steel's North Netherlands and South Wales assets are very well positioned for utilising those depleted gas fields. And that's not quite as outlandish as it might sound to those that are fresh to this type of technology or this potential solution, because the UK government recently granted its first injection license to a company called Pale Blue Dot Energy for a project called the Acorn Carbon Capture Project in the North Sea, which will use an ex-Shell gas field to do exactly that. And Tata Steel have been involved in a number of projects, both in the South Wales industrial cluster you see on the right-hand graphic there, and the Athos project you see in the North Netherlands on the left-hand graphic there. And whilst there are still significant challenges across utilising carbon capture and storage in this way, the initial studies and the work that we've been doing with external partners is extremely positive. And if I was a betting man, I would say this is a technology that will certainly run. If we move to the next slide. So There's also an opportunity not just to capture the carbon, but to use the carbon in industrial symbiosis. So Tata Steel are working with external organizations, big chemical organizations like Dow, looking at optimizing the industrial gases and the carbon that we produce, looking to turn that into further use that waste as an input into the plastics industry, for example, to utilize for manufacturing of totally recyclable plastics. So we effectively capture the carbon, put it into a product that can be 100% recycled, causing a closed loop and therefore delivering a circular economy. So there's lots of work with external industrial partners, and external industrial partners are critical to this work in doing that. If we move to the next slide. So one potential solution for decarbonisation of not just steelmaking processes, but wider industrial decarbonisation is the use of hydrogen. And in the context here of iron making, it's to use it as a reductant in the place of coal. And hydrogen reacts with iron ore in a very similar fashion to coking coal. But instead of the byproduct being carbon dioxide, the byproduct is H2O, or water. And as I say, it has much potential both in iron making and steel making, as well as wider industrialization. A process known as electrolysis, effectively splitting water is constituent oxygen and hydrogen is the first stage. And this has the potential to deliver clean, low carbon technology. But in order to do that, I mean, we can produce hydrogen by burning gas, but that's kind of robbing Peter's to pay Paul. We really need large amounts of renewable energy to do that in a very clean way. And therefore, this technology is very reliant on the primary energy mix of nations, whether that's the North Netherlands or in South Wales in the UK. We really need an enormous amount of renewable energy to do that. Of course, we've got potential and the opportunity across onshore and offshore wind in both countries to do that. But Tata Steel are working with a number of external parties on this technology, and particularly the Hermes project. We can see the little graphic there. And our work producing a small-scale 15,000-ton hydrogen production facility in North Netherlands. And there is, if you Google Hermes and Tata Steel, you'll see a YouTube video there, and you can get fuller details. But if we move on to the next slide. So I've already mentioned a number of challenges across these technologies and across wider industrial decarbonisation. And I think it's probably fair to say that such industrial decarbonisation will always be a challenge as we move forward. But I thought it was worth outlining some of these challenges specifically with steel. One, of course, being the scale. Steel is the most used metal in the world. It's also one of the most recycled materials in the world, and it's central to many sectors, from mobile communications to transport to building services. So therefore, we've got a big challenge in delivering decarbonisation across that. I've already mentioned the energy mix is a key challenge, and steel plants in Europe are already fairly efficient, have in place many circular economic processes, capturing gases, capturing heat, reuse of waste for internal processes and for other industries. So for example, there's a waste product within steel making that goes towards the manufacture of concrete, saving millions and millions of tons of CO2 for the concrete industry in obviously for concrete applications. However, for large scale industrial decarbonisation, I think the biggest single challenge will be across renewable energy and across investments. But there are also internal constraints, and the capital intensive nature of the steel industry, the long investment cycles and the life of assets means that there's a massive amount of forward planning and development required in order to deliver this over the timescale required for the targets that we're aiming for. And finally, there's a technology challenge. A number of potential decarbonisation technologies are at low levels of technical readiness. For example, hydrogen electrolysis is not at industrial scale today. So there's a scaling of those technologies and the development of those technologies that are going to be required. But if we move to the next slide. So as final part of the presentation, we want to talk about what we can do today. And some of that pathways to carbon neutrality is clearly being worked on today and will continue to drive delivery. But there's stuff we can be doing as a supply chain today. And if we move to the next slide. And it's a little bit of a complex graphic, but this was just the International Energy Agency released an iron and steel technology roadmap, and it was really interesting, and it certainly captured my imagination. But you can see the purple parts of that graphic. So the pie charts are how we're going to deliver decarbonisation across the steel industry, and the purple parts are about material efficiency. And it's nearly half of the decarbonisation comes through material efficiency. And by material efficiency, we mean designing correctly, designing optimally, having the full supply chain collaboration in such designs, in developing future products, in developing more durable and flexible products. And so there's a real important part we can play as an industry. If we move to the next slide. So we see an example here of seamless and welded pipe. So with the tighter tolerances of a welded pipe solution, the manufacturing tolerances, and also the flexibility in how you manufacture a welding pipe. You can manufacture welded pipes to the nearest 0.1 of a millimeter because it's made from coil, unlike seamless pipes, which require sets of rollers to make given diameters and given thicknesses. Therefore, you can save, our calculations show, depending on the size and the thickness, up to 16% material saving by just utilizing the benefits of that welded solution. So that's a classic example of how we can do that just by looking at the manufacturing tolerances and the manufacturing flexibility. And of course, engaging with the manufacturers, and not just the welding manufacturers, but I guess the seamless manufacturers as well, to drive that efficiency is a really important part of what we need to do as an industry. If we move to the next slide. And this is, again, a complex graphic, but the message here is that whilst we might move to thinner walls because of the manufacturing tolerances, but still meet a minimum design thickness, you might have a concern on pressures. But this graphic, and I won't go into detail here, is talking about how we can move to higher strengths to deliver the minimum requirements in terms of your design, but still deliver the weight savings. And those weight savings, of course, pass through every part of the carbon cycle, whether that's the manufacturing stage, we're manufacturing less steel, whether that's the transport stage, we're transporting less steel, whether that's the fit up, the welding, or however you put together your building services pipework, it's going to be faster and more efficient. So there's, the clarion call here really is to engage with your manufacturer or your manufacturing supply base or your supply chain to try and understand these efficiencies that are available. I think I'd say with just a couple of minutes left, we were hoping for time for questions. As my colleague hasn't joined and my technical colleague hasn't joined, I'm secretly quite glad we're running out of time. Oh, here he is. Here's Chris. But I think we've only got a couple more minutes for questions, but I think there's been questions typed throughout this presentation. We're going to capture all of those and we're going to respond, and the organising company are going to respond on all of those questions. But I think I'd finally say, I'd reiterate, there's lots of great work ongoing for decarbonisation, but I think the real lesson for us all is that the stuff we can be doing today with colleagues like Chris, who's now shown on screen, a technical colleague, an expert on the products that I've been talking about, expert on design aspects, that we can work together to try and deliver a more efficient and effective supply chain and capture that decarbonisation benefits through those efficient material efficiency early. And then, of course, that makes life so much easier when we're talking mass decarbonisation and mass carbon avoidance through those big industrial investments that we've been talking about and technologies in the next 5 to 15 years. So I guess that concludes the presentation. I don't know if we've got time for any questions. I don't think we probably have, but thanks very much for listening, and hopefully you'll get our names, both mine and Chris's, from the details of the organising committee, and we'd be happy to receive engagement direct as well as answering the questions we've received today. Thanks very much.